Doing today? Good? A couple of you are good. Some of you is still zombie mode. Did you guys notice Brian was back? Yay, Brian's back. Always a good thing to have the Brian back at the wheel. So we've got not much to cover, which is good. Class is winding down. We're just going to be getting into our Lecture 10 rendering activity. And this activity is going to be of particular interest to you because it mimics your week 4 assignment 2, almost to the letter. So once we complete this activity, you will have effectively done, or at least understand, everything you need to know to finish that week 4 assignment 2. So make sure you're paying close attention, asking questions, write stuff down so that you have all the information you need. And like I said, if you can do it in class here with Brian and I today, then you're going to be able to do it for your week 4 assignment 2, because there's 2 assignments for week 4. And the good news is it's not going to take a whole heck of a lot much longer than it will take for you to do it here in class. So it's a relatively short activity. Now, the other activity for week 4, UV mapping some assets that you built, that is going to take a little bit more time, obviously, than this activity. So make sure you're giving yourself enough time to do that, because if you take a look at those 2 activities, they're worth a pretty hefty chunk of your grade. So do not fall asleep here coming in on the end. Does that make sense? It's worth a lot, but it's relatively easy to do well on these, but it's going to take some work. So make sure you're putting in the time and you're doing the things that we talked about in terms of what we're looking for for your UV mapping assignments. Who can tell me one of the things that are a requirement for your UV mapping assignment? What's one thing, when you're laying out your UV shells, what's one thing I'm looking for? All facing the right way, right? We got to make sure our UV shells are all blue. Everything's facing the right direction, which you can go to View Shade UVs or Image Shade UVs, and that'll give you the blue and the red. And in the event your shells are facing the wrong way, you just use the flip tool to flip them over so everything's blue. So that's one thing that I'm looking for. What else? Happy little squares, absolutely. Make sure that when you're looking at your texture with the checker pattern on it, because that's all you have to do for the UV mapping assignment. You don't have to create a texture, so you're good there. But all you have to have is nice happy little squares all over it. And then we know that the resolution, or not the resolution, there's no distortion on your UV shells, because that's really important. That's pretty much the ball game why we're here. Let's make sure those those shells are laid out well. What's another one? All the squares are the same size on the same object. Things should all be the same size squares. Absolutely. How about my digital friends? You guys got one for me?
No seams.
No seams, right? Or minimize the seams. Absolutely. Whenever and wherever you can attach a seam, please do that. Yeah, hide them, a better term. Hide those seams. They're going to be seams. It's unavoidable, but it's always best to try to keep them to a minimum. And then, of course, do your best to hide them in the event that you can't make them go away. So using that move and sew is your buddy. All right. What else am I looking for? Who can give me another thing on those UV shells? And this one's important. I'm missing just one. In the correct quadrant within the 0 to 1 space. Make sure you don't have stuff floating around. That's a big ticket item, because if it's not in the 0 to 1, you don't get the precision placement of those textures and the ability to take a UV snapshot and then export that into another application and paint textures. So make sure that everything's in the 0 to 1. And then one last item, and it's specific to this class. About the shells, who can tell me, other than Superstar Aaron, you're disqualified, just on this one. Who can tell me there's one more thing about those shells we have to be careful about? They got to be blue, facing the right way, happy little squares, same size squares, everybody in the 0 to 1. Pancakes are round, and we place them next to each other or on top of each other? On top of each other, which we refer to as stacked, right? Do we stack our UV shells in this class? No, we have collage UVs. So we don't want UV shells on top of each other. So don't forget that one, right? So every shell gets its own little space. Everything's blue. Everything's in the 0 to 1. Happy little squares. And of course, same size squares. You do those things, you're going to be fine. You're going to do great. That is an easy high score. It's going to take a little bit of work, but it's not that bad. But if you ignore a couple of those things, that's going to hurt you. So, make sure you're doing those things that we're calling for, because that's how you ensure that you're going to get the best possible grade. Go ahead. If you look at your week 4 assignment, you've got 2 assignments. One of them is create a rendered image with a Maya file, which is what we're going to be doing today, this exact same thing as you'll be doing for that. But one of your assignments is UV mapping some of the models you've built. Week 3 and week 4 are different. Weeks 1, 2, and 3, we model. Week 4, we're UV mapping and we're rendering. Does that make sense? The instructions are on FSO. Take a look at them. Yep, do 2 of them. Yep. So, and then again, this is where you start to realize the way you model affects the UV mapping process. And you learn a lot from, okay, maybe I should not do this next time, because that is part of the process, part of the learning curve of how to successfully UV map your geometry. All right, so make sure you're doing that. Now, for today's lecture, as I mentioned, we are going to be doing the Lecture 10 render activity. So if you guys sign on to FSO and download, there's a file there. You're going to need that thing, so download it, get it on your desktop, because that's what we're going to be working with. And it's your, again, it's called the Lecture 10 render activity, and it's a zipped file. So when you unzip it, though, what you're going to have, is a project directory. So make sure you've got all that stuff available to you. And actually, while we're on the subject of project directories, one quick thing I wanted to put out there. You guys remember, for your week 3 turn-in, you guys have to build the project directory, right? Because I gave you the images, that's it. You got to work the rest of that out. So what you're going to have to do is create the Maya project, which is what we did day 1, if you recall. How do I create a project directory? File, new project, and then we go to upper right-hand corner, new, create this new project directory, and that will give us our file folder system. And then, of course, we're going to have to take the source images that I gave you and put them into this source images folder. Set your project to that folder directory that you just made, and then you're ready to go. So we've done that for you up to your week 3 turn-in, but then now you got to do it. So that is the process. Those are the steps. And if you missed, forgot, or what have you, it's all lecture 1. So make sure you go back and take a look at that if you've forgotten how to create your projects. All right, because from here forward, no one's going to make those projects for you anymore. You graduated, so you got to make your own at this point. So let's get into, oh yes, thank you, Stephen. No seams. All right, so let's get into today's material. Like I said, it's actually going to be a little bit of a shorter lecture today because we don't have a ton to cover. I don't like to weight classes heavily towards the back end because you've already got enough to do. There's no need to introduce tons of new stuff. So we're going to be a little bit lighter today. You'll be probably very excited about it. But make sure you are paying attention, writing stuff down, and doing the stuff with us. Because if you're going to have a problem, your better bet is to have it now. Because if we can't fix it in lecture, we can take care of it either in the Google Help session that immediately follows, or we can help you out in the lab. But you need to know how to do this for your week 4 assignment 2. So this is what you should be working on. Kid yourself not. This is the important thing. Does that make sense? Hell yeah? Awesome. All right, well, let's get started with today's fun. All righty. And I can move around today because Brian's here. I have a real hard time staying still, but now that you're back, I don't have to. All righty. Oh, did I not share it? I thought I did that already. Well, you know what it is. There we go. I thought it was up before, but I guess it wasn't. All right, well, don't forget to yell at me when I'm doing that, Brian. No, you can yell at me. I'm a big boy now. Actually, to be honest with you, my dad yelled at me all the time when I was a kid. Oh, yeah, I don't even feel it. Just it bounces right off. In fact, my tendency is to yell back. I am half ogre on my dad's side, so I got a pretty good yell. All right, let's get into lecture 10. Whee, rendering. So here we go. Rendering. Let's talk a little bit about rendering, because I think this is something that is kind of odd in its concept. Basically, what's happening with rendering is we're generating a final image. And a render is basically what the word render describes. Your computer is basically drawing a picture for you. And what you see is, in fact, a render. And if we look at, even if we're looking here at Maya, and what most people don't quite make the correlation here is if I'm here in Maya and I'm looking at something happening here on the screen, this is a render. This is the computer drawing me what I see. And what's interesting about this drawing is it's drawing so fast that it looks like it's in full motion, and it moves in what we call real time. Now, you guys are familiar with flip books, right? We've talked about these before. A flip book is a series of drawings on several pieces of paper, and the drawings are slightly different on each piece. And when you flip through them at the right frame rate, it looks like it's moving. Due to that phenomenon called persistence of vision, we perceive movement when it's not really moving, but we see that. Well, what's happening here is whenever I move and I navigate around through Maya, the computer is drawing me a picture of what I see, and it's drawing it so fast that it looks like a movie, but it's in actuality just a series of still images. It just draws really, really fast. Now, when it comes to drawing, the more simple the drawing is, the faster you can draw. Now, this is a very simple drawing. It's not overly complicated. I've got some highlight and shadow information. I've got some ideas of depth, but it's basically a very simple drawing. So the computer can draw it very quickly. This is what we call a hardware render. So it is drawing for me using a rendering engine, and rendering engines are basically a means of calculating how to draw a picture, right? So it's drawing for me relatively quickly this scene because this is a pretty simple scene to draw. However, we have many different types of rendering engines available to us, and each of them has their pros and their cons, and it's almost like their style. Much like we have watercolor paintings, we have acrylic paintings, there's all kinds of different mediums that we can paint in. Well, rendering engines have different means of creating those final images as well. And again, they're drawing and painting, but what they're doing is also incorporating concepts of light. So they're sort of using mathematical algorithms or formulas to figure out the behavior of light and surfaces so that what the render looks like the real world as much as possible in most cases. So again, this is a computer drawing for us, showing us what we see. And again, this is a hardware render. Now, again, in terms of that rendering concept, we're drawing a picture. And for animation purposes, if you have at least 24 frames that you're flipping per second, it looks like it's moving relatively smoothly. If that frame rate drops, it tends to look a little bit more jerky. It tends to get more smooth. And then there's a point where it's just, you could have a billion frames a second. It doesn't get any smoother. But the most important concept being that if you're drawing something very easy, something very simple, you could draw it very quickly. It doesn't take very long at all because there's not a lot of detail. Same thing with a computer. Hardware render, very simple, easy to draw, very fast. However, if you're drawing something very complex with a lot of detail, that's going to take longer to draw. Well, a computer's the same way. So again, if you take a look at video games, when you're looking at the larger platform games, they're able to draw much more quickly, and therefore as a result we've got higher resolution images, better quality image, smoother looking animation, nicer textures, everything looks a little bit more realistic. when you get to smaller game platforms and handheld game platforms, stuff doesn't look quite as good, but that's because the computer can't draw fast enough to make that stuff move in what we call real time. Because the key to video games and what makes them super fun is the fact that they change in real time. So when I'm running through an environment, if I turn my gaze to somewhere else, the computer is drawing what I see, and it does it so fast that to us, we perceive that as real time or actual time. And that's how fast it has to draw. Does that make sense at all? Okay, because I'm sure you guys have played video games that your computer couldn't quite keep up with, and you had to like turn off some of the cool things that game did because you just can't process fast enough, and you get lag where it doesn't quite, give you what you want. You got to wait a little bit for it to finish. And again, that's due to how much math is going on in the scene and how long it takes it to figure that out. Yes? Exactly. That's exactly why. Because in terms of our example here, if I was to model this character, there's a lot more detail, a lot more polygons. It's going to take the computer longer to draw them. Yep. So that's why when you're modeling assets for a video game, in many instances, you're given poly limits, and it's like a budget. Build this object, but keep it within this budget because you can only have so much on the screen at one time for the computer to still be able to draw in what we call real time to make things seem real. Does that make sense? So that's why we have those considerations in terms of our modeling. It's not just build whatever you want and make it look awesome. There are parameters for it, otherwise it won't function. Does that make sense at all? Hell yeah? Okay, my digital friends, you guys on board too? Yeah, there we go, awesome. I just want to make sure that they were getting it and it made sense because it's important to realize how that works. Okay, so now the good news is we have a little scene. Again, if you go to your Lecture 10 rendering activity and download the file, you will be able to follow along with me, and then we can do this activity together. And again, this activity mirrors your week 4 assignment too. So if you can do this, you're going to be okay. So make sure you can do this because now is the time to figure out if you can or cannot execute this particular activity. So if you go to the activity, you will see, again, there's, all those happy little pictures in there. This is an example of what the scene will look like when you open it. This is a rendered image that we've generated, and this is, again, our goal. You're going to get a fun little file to download, so make sure you've got that. All right, so when you click that, you will end up with this file right here, Lecture 10, and I'm just going to copy this and put it on my desktop so that I've got it. So then when you've got it here, you double click on it, zip, and now you have, again, a Maya project directory, and anytime we're going to go work on a project, we have to set our project to that directory. So I'm going to go to File, Set Project, and on my desktop, I'm going to find my Render 10, or my Lecture 10 render activity, and then File, Open Scene, and you'll see there's a file called Render Activity, which you'll open up. All right, so here we are in our rendering scene, and what you're going to notice probably right away is that we have a camera that we haven't had in the past, and this is called our render cam. And what's very important for you to realize is there are many cameras in Maya, and they do all kinds of fun stuff to help us do our job, but those are like working cameras. Those are our eyes. That's how we navigate through this world that we're building. Now, when we're actually filming, when we're making our little movies and what have you, rendering images, we're going to have actually a separate camera for filming with, and we don't move that one. We're going to keep that one stationary, and that's why we've created this thing called the render cam. And it's very easy to make a camera. You can make one anytime you want. Some of you have had to do that at one point or another. you can go to your create menu in order to make one of these guys. But one of the easiest ways is if you go to panels and then you come over here and you just figure out what kind of camera you want. The perspective camera, if you wanted another one of those, you would go to perspective and then choose new, and that would allow you to make a new perspective camera. And that would be called perspective 1, and then perspective 2, what have you. And then you can rename those. And that's what we did, was we ultimately renamed this as Render Cam. Now, what's also different about this camera is we've got sort of this gray field here. And what we've done is we've activated our render field, or our film gate for our image. So based on the resolution parameters that are in here already, we sort of created this box. And it's basically a guide to help you realize what is in and out of the shot. So whatever you want to have in your picture, it needs to fit inside this open area. Anything that is in this gray area is not going to show up in the scene. So just like a camera, you know, with the little etchings on the glass, you know what's in and out of the shot, you can use this to help you figure out what is within frame and not within frame. Now that you're in here and we're looking through the render cam, the very first thing you're going to notice is the camera doesn't move. That's because the camera is currently locked. So we have to unlock the camera. And this is very important. I get a lot of students who ask me, you know, can you lock things and how do you do that? So here's where we're going to get into that. Now, if you don't unlock this, it's only going to render from this position. You can't move it. So if I get a render from this position, I know you missed this part of the lecture. Does that make sense? I know when you started working on something else. So how do I unlock my camera so I can move it? If you go to the particular camera in question and go to View, Select Camera, what that will do is literally physically select the camera you're looking through at the time. So you'll have the statistics for that camera available to you. Attributes. So I'm going to go to the channel box here though, and you'll notice that all of my attributes for this camera have this little gray bar next to them. And that's an indication that those channels are locked, and that's why I can't move the camera. So if I try to move around in here, no matter what I do, it's not going to let me move. So what I want to do is highlight these attributes with the left mouse button. And I'm highlighting the words. I'm not over here in the numbers. I'm over here on the words. And then I hold down the right mouse button and you'll see unlock. And above it, lock. So how do I lock things? With that. How do I unlock it? With this. So I unlock those attributes. The gray goes away. And then all of a sudden, lo and behold, oh, look at that. I can now move this magical render cam. Does that make sense? Get a hell yeah? Okay, good. So what I'm going to do is I'm going to set up the camera here on my scene. We've got the Peppermill in there for you to use as subject matter. And what I'd like you to do is just find something that looks relatively interesting. We're actually, next class, we're going to be talking about composition and how we can improve the quality of the image that we create. Next class. So don't worry about that today. But for today, let's just line up something that looks relatively interesting. And then we'll be able to do some renders and just see how this whole rendering process works. And what I'm going to hope to teach you today is a good rendering workflow, because like anything else, you want to have an efficient way of arriving at your final work, whatever it happens to be. All right, so once you've got this lined up to where you'd like it to be, the very next step is we have to make sure we activate the rendering engine that we're going to use. Like I said, there are many different rendering engines available. You have several that are set up to work with Maya. As I said, you've got your hardware render. There's Gesundheit. There's also the Maya software render. And but we are going to be using another renderer called Arnold. And the Arnold renderer is, we actually used this once already when we were creating the ambient occlusion pass for our Peppermill last class. But now we're going to have it actually, Gesundheit, draw images for us, not just create textures. Now, the Arnold rendering engine, as I mentioned last time, is a third-party plugin, and what that means is a totally different company made it, but they made it so it would work with Maya. So what they do is they will make a version that works with Maya, they'll make a version that works with 3D Studio Max, you know, whoever they want to have using their rendering engine. So what we do have to do is turn this thing on, because by default it's not turned on. So I'm going to show you the steps for how do I turn on the Arnold renderer. And again, if you use the link that we gave you to download Maya, you will have the ability to download and utilize the Maya, the Arnold renderer. If you got Maya from somewhere else, you know, that's where it starts to get iffy. Will I have the things I need? And that I do not know the answer to. So what I would say is if you did not download the version of Maya that we gave you the link, do that now. Make sure you've got that one. And then you will have this capability available to you. And that won't destroy your previously created files. There won't be any problems there. Just make sure you're using the one that we gave you. Yes?
All the rendering options do something specifically different.
Slightly different. That's a good question, because there are different rendering engines. Like I said, there is a hardware rendering engine, and it literally would give you an image that looks very much like what we see in the viewport. There's also the software rendering engine, which does incorporate more light and shadow information, but it's still a more simplistic render. You can put toon shaders on geometry, and then stuff starts to look more cartoony. It sort of blends it to make it a little bit more 2D than 3D. I don't know if you saw that show Slugterra or anything like that, but that's very interesting visually. But the intention was to make it look 2D, but it was definitely a 3D project. So it's interesting how they do that. But anyway, they have different rendering engines, just like there are different styles and mediums to paint with. So, and that's the way they work. And Arnold is one of those rendering engines like Mental Ray or V-Ray, where we're trying to simulate reality. So what we want is a rendering engine that behaves, calculates surfaces and light very much like it happens in the real world, because largely we're using those in instances where we're going to take CG items and composite them into real world scenes, and if stuff doesn't match, it looks silly. So a lot of times when we have an interaction between CG and live action, it's critical that that stuff behaves and lights similarly. But it's a good question though. All right, so let's take a look at turning on the rendering engine. These are the steps for making sure it's on. Again, I showed you guys this last time, but it bears repeating. If you go to Windows, Settings and Preferences, Plugin Manager, this is where all of the third-party plugins are housed. And again, the third-party plugins are plugins that are made to work with Maya, but are not turned on by default. Maya takes long enough to launch as it is. So if everything was turned on, it would take even longer. So what I'm going to do is scroll down to Chinatown, and you will get to eventually in here. Oh, here we are in the Arnold section here, and we've got the MTOA bundle, and it is the Maya to Arnold bundle. And all you have to do is check the loaded, and if you check auto load as well, it'll be on every time you turn it on. And then you just hit refresh. And then that loads Arnold for you. And again, you'll know it's available because when you take a look at your handy dandy copy of Maya, you'll see Arnold there in your main menu items. And then when you go to your render settings, it will be available there as well. So now that that has been activated, we're ready to go. So we're going to go to Window, Rendering Editors, Render Settings. And Render Settings is where you're telling Maya and whatever rendering engine you're using all about the image that you're trying to create. What type of image is it going to be? What frame? What camera am I rendering from? There's a lot of information that you have to explain to Maya and your rendering engine so that it knows what to do. And this is sort of the instructions or parameters for your objective. So up here you'll see there's different rendering engines that you could set it for, but we want to set it for the Arnold renderer. And again, that will be visible once you load Arnold. It won't be visible until you do. In terms of things that we need to worry about, right up front here, image format. Image format is asking you what kind of image you want to create. Okay, and there are many different image types. For this class, we are doing renders with the TIFF image type. We are doing TIFF. So that is a specific technical directive. Do you think that's something I'm grading on? That is correct. If you submit a file by any other file type, anything else, in fact, if you leave it at EXR, I'll know you didn't even mess with the settings. If you give me a file type of any other variety, you get a 0 for the render. You cannot give me anything other than TIFF, because that's what I'm asking for specifically as a technical directive. So do make sure you give me the correct type of image. Now, in terms of, well, how do I set that? What? Because that seems like a bad thing if I miss it, and it is. What you want to do is go to where it says image format, click on the drop down, and you'll see that there's many image types in here for you to choose from. And you'll see TIFF is one of the options. So just make sure you pick it. Choose TIFF. It's very simple, very easy to do. Now, in terms of questions I typically get, well, why TIFF? Why, with the myriad of file types, do you choose that? Well, there are a number of different file types that you can create images from, and they all have their strengths and their weaknesses in terms of what they can do. But what I like about TIFFs is it's a good quality image. There's not a lot of compression to that image type. JPEGs, for example, a lot of compression, so they're usually pretty shoddy in terms of trying to create art with them. But in terms of the TIFF type, not very much compression in there, good quality image, and probably one of the most important attributes of the TIFF file type is that many other applications use TIFF files easily. I'd like you to think of image types as almost like languages. So in terms of applications, other applications, because this is going to go somewhere else. This is not the last stop for this stuff, not by any means, because we're going to go into compositing and stuff like that afterwards. So this is not the end of the journey. This is the end of our side of the journey. But in terms of applications, there are a lot more applications that speak TIFF than other file types. Does that make sense? So it depends on the platform that's being used. It depends on the application that is next in the pipeline for that thing. And again, this is technical information you will be given by your supervisors. Hey, make sure you're creating this kind of file type. They're going to tell you that. So it's not, you don't have to guess. They're going to tell you. But the point is, when they tell you, that's the one you got to give them. Does that make sense? So where ours is going, it needs to be a TIFF. So if you give it a different file type, it does not speak that language, and therefore it's the same as if you didn't do the work. Does that make sense? Make sure it's the correct file type, TIFF. So we set it for TIFF, and of course, if we were doing multiple images, we could make adjustments to that. Luckily, we're not doing any multiple images here, but we could make all kinds of changes to the parameters of the image in terms of its size. We don't need to do that. You can just leave everything at its defaults because we set that up for you in advance, but know that you could change the resolution of the image. Gesundheit. All right. Now, once you've got that set, the very last thing we want to touch on this particular window is make sure that your renderable camera is set for render cam, because that's the one we want to render from. Now, you could tell it to render from any camera really that you wanted to, but we want to make sure it's set for render. And this still might not guarantee that it will do it, but we got to make sure we set it here at the very least. All right. Now, once that is all in place, we can close this window and we can open up Window, Rendering Editors, Render View. And your render viewer is basically letting you see what it is you're actually rendering. And there's some tools up here that you can play with, but what we're going to be playing with is the icon that allows you to render a frame, and the icon right next to it, which will allow us to render just a field within the frame. And then most importantly, these two icons here, which are basically hang on to a frame, and I'm using hang on purpose because it's not saving. It's just kind of hanging on to it. And get rid of a frame. So if you've hung on to something and then you don't want to keep it, you get rid of it. Saving is a whole other thing. I'm going to show you that as well, obviously. But just be aware, this is how we compare renders. All right, so once we've got this set up, and again, the scene has already been built for you. There's lights in there and everything. For the week 4 assignment 2, you're just going to bring your objects in. In this instance, we have the pepper mill for you, but that's all you got to worry about. All right, so What I'm going to do is, if you look over here at this icon on the far left, this is your render current frame. So if I click on this, it's actually going to start rendering, and the Arnold rendering engine is going to start drawing a picture of what you see, or what that final image would look like. And it is incorporating the geometry, it's incorporating the lights, it's incorporating the surfaces and the materials, all that fun stuff is in there. So it starts rendering, and you see it takes time. And luckily, again, it starts in the middle, and it just starts rendering out, and it starts to create the scene. Now, if I look at this, again, it tells me the size of the image I'm creating. It's telling me what frame I'm rendering. It tells me how much time it's taking, and that becomes a big deal as we go. All kinds of information in here. But first and foremost, right away, I can see this is not the correct camera angle. All right, I told it to render from the render cam, but this is my render cam view, and that's not what I'm seeing. And this happens on occasion with Maya, often enough that I make a point of pointing it out. Sometimes this icon will render from the wrong camera, regardless of what you've set it for. So what you want to do is, you notice here on the main interface, there's another render current frame button. It looks just like the one over here in your render viewer. Just click this one, and way more often than not, that one will render the correct image. Does that make sense? And it's just a weird thing I've noticed about Maya in general. Some of its sort of periphery windows will have issues on occasion, but the main interface works great. So if you're ever having a problem with a periphery window, see if the same icon or tool is available on the main menu, main interface, and then that one will most likely work. So don't be daunted by the fact that perhaps you're not getting what you want from one of these sort of external windows. All right, so it's starting to render here. You can see I'm getting some pretty nice shadows in here. Looks pretty good. You can see where the light is falling on the desk. And again, there's a Peppermill in here now, but you're going to put objects that you built in here for your week 4 assignment too. And it's sticking them right in here. And you can see it takes some time for it to render. And incidentally, if you hit the render button and you realize, oh, it's rendering the wrong camera, or oh, I forgot to put something in there, if you want to stop the render, you have to hit your escape key. So if you look at the upper left-hand corner of your keyboard, escape will stop the render, okay? So if you need to stop it, that's where you do it. Okay, so now you can see, again, there's a lot of information about this render for me that I can check. Again, it's telling me how big my image is, what I'm using to render, what frame number I'm rendering from, and you can see it's on 95 on my timeline, how long it's taking me. And my first render from further away, that was like, what, 36 seconds or something like that? I don't remember exactly. But I'm up to 1 minute 19 seconds already. And that's because I'm a little bit closer, so there's more detail taking place, a lot more attention to the surface, so it takes a little bit longer to do. Does that make sense? It's like finer detail. And this is the concept that you have to understand is, as we render, the more detail we're asking for, the longer it's going to take to generate the image. Does that make sense? Okay. So here's my first render. Yeah, it's looking pretty good. My object looks like it's kind of in the shadow. It's not really standing out very much. But you know what? This is my first render. I'm going to hang on to it. So what I'm going to do is I'm going to click this icon right up over here. And this basically saves that image. And what it'll do, well, it saves, hangs on to that image so that I can do a comparison using this slider. So I've got this first one in there. And what I'm going to do is I'm actually going to move my object slightly and try to get it underneath this light a little bit more, draw some more attention to it. So again, I want to do another render. So I'm going to come up here and click this icon up here, and it's going to do another render for me. And you'll notice that when I hit the render button, I can't really do a whole lot else. And I like to refer to it as being sort of a prisoner of the render, because you can't do anything while the rendering engine is rendering. And you really shouldn't be doing anything. You don't want to be working on another application. You don't want to be on the internet surfing for videos of people wiping out on their snowboards. really you want your computer doing one thing and one thing only, and that is generating these images, because it takes a lot of time and processor power to make these images. So you really don't want it doing anything else. So what I typically recommend during the rendering process is make sure you, turn off hibernation, turn off screensaver. I will often disconnect myself from the internet completely, just so that there's nothing going on between my computer and the rest of the universe. I really just want it to be doing this one thing, and that's generating images. And you can see it takes a little bit longer. It's calculating some new information. But I'm getting some nice shadows in here. I'm seeing some of the nice smoothness in my geometry. And again, this is where you really start to see modeling issues, because once you put light on it and you start rendering out these images, again, light is either your best friend or your worst enemy, because it will show off whatever is not so great about your models when you light it and you render it. So I'm at a minute 19, the same as it was before actually, but it's looking a little bit better there. Let's do a comparison. So what I can do again is I've got this image here, and make this a little bit smaller so you can see. So now I can use this slider and sort of compare. How does this look compared to where it was? All right, let me hang on to this image, and I think what I'm going to do is push this object back in that direction a little bit more. So I'm going to come back in here to my main interface, push that back even more. Now, again, I want to hang on to this image. I don't want to render the entire scene. All I did was I took this pepper mill and kind of pushed it a little bit that way. So what I'm going to do, instead of waiting for the whole thing to render, which can take me a minute and 19 seconds, I'm actually just going to render a small area. So what I'm going to do with my left mouse button is I'm just going to draw a little box, and that's going to create a field. And then I can click this icon here, which is render the field, the selected field, and it's just going to render what's in here. And that's going to go much faster. So I don't have to wait for the whole scene to render. I can just render the little bit that I'm interested in. And then when it turns out, oh yeah, that looks pretty cool there. Let me do the whole thing now, and let's see what we got. So I'm going to do another render, and then I can compare these renders to each other. Does that make sense? And we could do this for placement. Where you really do this a lot is with lighting. Now we are at the distinct advantage in that somebody else lit this scene for us. In fact, the guy who teaches shading and lighting for you guys, when you get to that class, he lit this scene so you didn't have to light it. Created the lights and placed them in such a way that it creates something visually interesting. But what you will find when it comes to these projects is lighting is one of the most time-consuming aspects of these types of projects. It takes a long time to light things well. In a lot of instances, you'll take lights and you'll do a render, and then you'll make an adjustment to the light, and you'll do another render, and you're just doing a comparative study to see which gives you the best result. And that's why it's very time-consuming, and you have to have a methodology from light to complex, much like modeling, where we go from light to complex. Otherwise, it's inefficient and it takes forever. Because as you can see, as the increase of detail, more lights, more things for the renderer to calculate, the longer the rendering time is. So you don't want to take 12 hours to do one render just to find out, is that light in a good position? Okay, I got to move it again and try it again and then wait 12 hours. So we work light and efficient early, just like we model light and efficient early. Same idea. All right, so this is looking better. I like that. Let's do a comparison. As always, you want to see where you're going and where you were to kind of figure out how things are going in a positive light, no pun intended. So I can sort of follow the transition there. Go ahead, you have a question?
The slider bar there?
Yeah.
Mine doesn't have that.
Oh, sure it does. You gotta hang on to several images to have it visible. If you haven't kept your images by clicking this icon, you don't have anything to compare. Does that make sense? So once you start comparing, all right, so I'll hang on to this one. And again, this is looking pretty good. That's not too bad, but you can see you kind of tinker with things a little bit to try to get something to look better. Does that make sense? And whether we're talking about lighting or placement, it doesn't make a difference. We're comparing rendered images. Now, once you get the object where you want it, and you feel like, okay, that's looking pretty good. I kind of like the way the light's falling on that surface. It is accentuating it somewhat. Again, I'd like you to think of that desk as like the stage and the models you built, like the actors that are on that stage, and you're trying to show them off. Look at what I did this month. So just try to think, you know, if this is a movie, how do I tell a story? How do I make this look visually exciting? Again, we're going to delve into more of that next class. But just so that you're aware, that's what's going on here. All right. Now, once you're feeling pretty happy with the image, here's where we can start to increase the resolution. And much like when you're doing a drawing, we start with sort of a rough light sketch, and then we kind of get to finer, final detail on things. We do the same thing with lighting and rendering. So we're working with sort of a light sketch at this point, but now that we're pretty happy with the way things are looking, now we're going to start turning up some of the quality controls to increase the quality of the image we're getting. Now, the way we'll do that is we're going to go back to our render settings window. So we go Window, Rendering Editors, Render Settings. Whoop. Rendering Editors, Render Settings. And then what we're going to do is go to this next tab called the Arnold Renderer. And when we click on this tab here, you'll see up here Camera AA, and it's set for 3. And you can think of this like anti-aliasing, or you can think of it as quality. How do I increase the quality? Well, it's set for 3. What does 3 mean? I have no idea. It's just an arbitrary value. But if I want to increase the quality, I want to increase the number, right? That's the logic. But here's the important part. When it comes to working with Maya, anytime you're dealing with a field where you have to put a number in, you want to work with halves and doubles. Because if you hit undo, Maya's not going to remember this used to be 3. Does that make sense? So what you want to do is go in halves and doubles. So if I want to increase the quality of this, I'm going to go from 3 to 6, because that will double the number. That way, if I'm not really happy with what I'm getting, I know it was previously 3 because it's currently at 6. Does that make sense? Easy to pop around. So just anywhere in Maya where you have to enter a number, try to use that methodology. So I'm going to make this a 6. All right. Hit enter. So now it's set for 6. And I want you to note we're at 1 minute, 19 seconds here. I'm going to hang on to this image. And now I'm going to do another render. I'm going to come over here and hit render. And then we're going to see what we get. And then we're going to compare the two. How much better is it with the increased quality? Now, who can remember what do I have to press if I want the render to stop? Escape. That's very important because some of these renders start to get pretty lengthy. Render times can vary, and they can be huge render times. For example, how many of you guys saw the movie Transformers, the first one? Right? Okay, you saw Transformers. One frame, a single image from that movie took 40 hours to render. 40 hours for one frame. That's a 24th of a second. Does that make sense? It took 24 of those to make 1 second of screen time imagery, right? So that's kind of a problem if you're in the middle of a render that takes 40 hours and you go, oh, whoops, that's the wrong camera. Does that make sense? So we have to be able to kill the render. So escape is your buddy so you can stop that render. Now, in terms of speeding up renders, there's all kinds of stuff you can do, but typically what the industry does is they utilize what we call render farms. And a render farm is basically a whole room full of computers, and they're all working on one thing, and that's the creation of images. And they're huge. And that's what all they do is calculate, crunch numbers, and ultimately they create an image. So again, depending on the complexity and the size of the image, it's how long it takes to create that image. And sometimes those times are pretty lofty. Oh, yes. If you notice now that we're rendering, do you guys hear the fans coming on? Because your processor is working harder than it's ever worked before. The graphics cards are whizzing away. They're doing crazy amounts of math, and all this stuff is getting very hot. So what's happening is the fans are kicking on to try to cool that stuff down so it doesn't melt, because that does literally happen. It's funny because, I mean, if you listen to my computer, it sounds like it's taking off. But something that I recommend highly along those lines please don't put your laptop on the rug or on a couch or something. Make sure you've got good circulation of air underneath there, because if you don't, those things get really hot and you can melt stuff. That's a big ticket item. And something Brian just reminded me of that's very important. Make sure your laptop is plugged in, because it actually is using different graphics card capabilities when it's unplugged versus plugged, because one is more cost efficient in terms of battery power use. So make sure you're plugged in, because that makes a big difference in terms of the speed and the quality of the images that you're generating. So do yourself a huge favor, make sure you're doing that. And as I said, turn off your screensavers, hibernation. You really don't want anything on except the fact that your machine is rendering. In fact, when you guys get more advanced, you will learn how to use the terminal, which is basically a screen that gives Maya instructions, but you don't have to have the Maya interface up and loaded to run it, because everything that you see on your computer screen, all these pretty pictures, your computer has to spend some time and effort to draw for you. So if you can have all that stuff turned off, all you're doing is increasing how much power and capability is applied to just the rendering process. So like I said, you're going to learn how to use do terminal renders, which are great because it's just like a DOS interface. It's not very complicated, and you just tell it what you want it to do, and it doesn't have to put all this nice, pretty pictures in your face to help you do this. But at any rate, you can see the images are still rendering away, and it does take a good amount of time. And incidentally, you might be wondering, why do we always use Lamberts? Why can't we use, steel or, glass or, some of these other really fun materials? That's going to cause a lot of additional calculation time, because anytime we are calculating the behavior of light, we're talking about reflections, refractions, color information, concepts of radiosity and things like that. All of these things come into play when we're calculating the behavior of surfaces. And luckily, Lambert is a very dry, chalky surface. There's not a lot of reflectivity, and that's what keeps those render times down and reasonable. As beginners, it's a safer way to go about it. The shinier it is, I know you're like, I love shiny. I love shiny too, but that means time is what you're looking at. So we're trying to keep that to a minimum, because there's nothing worse than my project is due in 5 minutes, and this render won't be done for another 20. Does that make sense? You don't want to be in a situation where your project will not render in time to submit it. That's bad. So now, should you play with the materials? Should you play with the rendering engine and learn new stuff? Absolutely. But do this. Make sure you've got everything you need to turn in a folder ready to go, right? Here's my project. It's done. It follows all the parameters that were asked for the class. It adheres to everything I needed to do. It looks beautiful. I'm very happy with it. I'm very excited. I can't wait to turn this in. How much time do I have? Oh, this isn't due for a couple of hours. Okay, now I can play. Does that make sense? You've earned the time to goof off and play with stuff and see what it does. And, oh, I know, let's make everything glass and see what that does. Please, by all means, explore. But make sure you've done the work first that you have to turn in. Because what happens is sometimes you get really excited and you're like, oh, I want to go explore into all this other stuff, and you forget to do what you're supposed to be doing. And then, oh no, my stuff's not done. I got to turn it in. I'm not happy with it. We know how that goes. So always a good idea to try to make sure you've got what you need to turn in first, then play all you want. So in terms of the rendering engine, it's all done. This is my new image. When I look at the time, I'm up to 5 minutes and 23 seconds. So all I did was take my quality and take it from 3 to 6, and now I've way more than doubled what it took me to create this image. So you can see how quickly it can get away from you. So the next thing I want to do is compare the two images to each other. So now that I have more than one image, I have access to that slider. And what I'm going to do is do a comparison and just see. Here was my image at 119, and here's my image at 523 in terms of the times. And what I'm doing is I'm doing a comparison to see if one of them is significantly better than the other. And in terms of, well, where do I go to look and see? What you want to do is look into the shadows, the quality of the shadows there. How smooth are they? Let's look at the edge where the shadow meets the surface. Let's look at curvature on the objects. Let's look in the background. This is where we're going to try to see if it's a little bit grainy, if it's a little bit rough, and then it looks significantly better as a result of the increased render time by increasing the quality that we're asking for. So again, you can just move this slider until you figure out, you know, which one is giving you the best image. Now, once you've decided, you know what, it does look better with the increased quality, this is the one I want to save. These are the steps for actually saving the image. What you're going to do is you're going to go to your viewer and then go to File, Save Image. All right. And again, it's going to send it to the images folder to where you've set your project. So make sure you've set your project. And again, you're going to use the naming convention, Gold Steve _ final render _ 3DF _ 1803. And you'll notice that it's set for TIFF. If you needed to, though, you could click the drop down and then find TIFF in this list of files. Realize that there's a scroll wheel, so you might have to actually look for it, but they're alphabetical, so if you don't see T, just keep going down till you get there. So make sure it's a TIFF file. All right, and then you hit save. And what you will see is that oh, you are so demanding. All right, so what we see is if we go into our images file folder, there's my rendered image, and this is an image you could literally print out and put on your refrigerator, you know, load onto an internet platform of some kind, and and show off your work, what you accomplished in your very first month. Now, in terms of your week 4 assignment 2, this would be the process, and it didn't take that long. You can see this is pretty short. This would be the process for the creation of the image. However, the image isn't the only thing I'm asking for. I'm also asking you for, did you freeze transformations on your file? Do you have layers for each of the objects? If I'm asking you for those things, what else do you think I need other than this image? What's that? I'm going to be deleting history. I'm going to freeze transformation, but how would I check that? Can I do that with a picture? I need the Maya file. So not only do you give me this beautiful image of what you've done this month, I need the Maya file too. So for week 4 assignment 2, I'm going to get an image and a file. I can't tell you how many files submissions I get where they give me just the Maya file. There's no render. So they get a 0 for the render and a 0 for all the things associated with the render. That's bad. I also get submissions where I just get the image and no Maya file. So I give you credit for the image, but all the Maya related things I can't grade. Does that make sense? So make sure I get both. Week 4, assignment 2, I get the Maya file and the rendered image. Does that make sense? Okay, now in terms of the technical requirements for that Maya file and that rendered image, where do you suppose I'd get those? Where's that? That self-grade document, right? It lists it out. Week 4, assignment 2. Freeze transformations, put layers on there. All that stuff is in there. So you can't miss if you use the document. You're going to do great. But remember to give me all the things I need. And again, when you work right up to 11:59, that's when we forget stuff. That's how it works. So give yourself enough time. Make sure you've got everything you need and submit it. You're going to do great. Was there a question? I thought I saw. No? Really? Oh, there you go. Oh, yes, I know. It's so hard. You know what? I have to give you like a flashlight or something there. The question light.
It wasn't actually a question, but it was back to these things overheating a lot.
Yes.
Those like rubber keypad things
Yes.
are really bad for MacBooks.
Oh, I'm sure, because it doesn't allow it to breathe. Because it does kind of breathe through the keys. So yeah, having that rubber stuff on top. Yeah, it looks cute. I love it, but yeah, it kind of makes it melty. So yeah, be careful what you do with your laptop. You know, for the same reason you don't leave your laptop in your car with the windows up, you know, parked out in the parking lot all day in Florida. You know, it's bad. Technology does not like extreme heat. Technology doesn't like extreme cold. Let's face it, technology is really fussy. So we got to be careful with it. All right. Was there anything else, you guys, in terms of this? This makes sense, what I'm looking for, what I need you to do? And again, this is not very time consuming. So this is an easy one. Make sure you're getting these points. It's going to make a big difference in your grade. There's a lot of stuff due week 4, value-wise, but all stuff that you can do. So get these points. You can really turn your grade around with this stuff. All right. All right. So let's take a look. All right. Now, in terms of your skill check, the skill check for today is basically taking what we learned last class and what we learned this class and bringing them together. We've given you a scene file, this one, and it's got an object in there. And what we want you to do is bring your jar into the scene. You know, hopefully you've created an AO pass for it, because that's what we should have done this skill check before. And what we want you to do is bring that jar into the scene and then connect the AO pass texture that you created for it to it, and then render that out so that you get an image of the environment that we've given you with the jar that you made with the AO pass on it. Because ultimately that would look the best in terms of the quality of the image. So a couple of quick things I want to show you. The importation of objects. Very, very simple. In terms of trying to bring an object into Maya, all you have to do is go to File, Import. Couldn't be more simple. So you go to File, Import, and then you navigate to your object and bring that in. So I'm going to go to my skill check file folder. I should have a jar in here. Yeah, there's the one that I've already UV'd, so I don't have to do that again. And in terms of the object, when I bring it in, it's going to appear in my at the origin. And in terms of the placement of objects, it's kind of hard to place using your orthographic or using your perspective view. So what I'll do is I'll use my orthographics, because I can just move stuff more quickly. And it looks like my jar is definitely the wrong size. I'm going to have to make it the right size. But what I'm doing is just trying to get it ballpark where I'd like it to be in terms of its placement. And it's definitely too big. And I'm going to pretend I know what size to make that, because I don't know off the top of my head. But you guys will have to look that up and make sure you make it the right size. All right. I'm going to place that within my scene. And when I'm happy with where, make sure. All right. And my jar will need a layer, because you always want to have a layer for everything. Add this object to that layer so that it works. So now that I know that that's in there, does that make sense? Make sure that's in there. And then in terms of my jar, if you remember, I created that really cool AO pass for it, right? And that's going to be also in my source images folder. So I'm gonna have to go back to my jar where I put it, and it is in my skill check files. It's in my source images folder. There's my AO pass that I created. So I'm going to get a copy of that, and I'm going to put it into the source images of my project that my project is set to for the jar, so that my AO pass will appear on there. So of course I'm going to have to check the attributes for my jar in terms of what it's made of. So I'm going to go to Window, Rendering Editors, Hypershade, because that's where all my materials live. All right, and I've got my Is that what my jar is made of? No. All right, well, I'm gonna make a new material then. I'm gonna make a new Lambert. This will be my jar material. And then I wanna make sure that I hook up my AOPass texture to it. So I go to the color channel, I go to the file node. And again, this is all stuff we did last class, so this is like a refresher for you. Go to the file attributes, and of course I plug in my texture. All right, and if I press 6, I'll be able to see, oh, I didn't apply it yet, hold on. There's my jar material. Make sure my jar is made of that material. And something that comes up every once in a while when you're applying a texture to an object, sometimes you'll be like, whoa, what's this weird, looks like it's in X-ray mode, but it's not in X-ray mode. What's going on there? And something that happens sometimes when you connect textures is not only does it connect the color channel, but it will also connect something to the transparency channel. And that's where you get this sort of weird X-ray looking thing. And all you have to do is come to the word transparency and hold down the right mouse button and choose break connection. And then what that does is it removes that transparent element, and then now that's no longer a thing. So, and what you will notice with my jar is that my scene looks much more interesting in terms of the scene in general. Since I've got this nice AOPass on my geometry, it really kind of makes it stand out from everything else. And that's not a requirement. You don't have to connect the AOPass to your geometry, but you can see it looks pretty cool. And as you remember from last class, the creation of the AOPass is not all that complicated. So if you want to, for your final render, you can do that. So this skill check would represent the maximum you could achieve in terms of trying to render your final scene out. So if you want to create an AOPass for your objects that will be in your final scene, you can. You don't have to though, it's strictly optional. But for the skill check, you do have to do it, at least with your jar, so I know you know how to do it, that's all. Yes? What's that? No, it doesn't reduce the rendering time. In fact, if anything, it probably adds a little bit, but not a ton, because we're not making, that texture's not too big in terms of the parameters. I think we have it rendering at like 512 or something like that. Yeah. Yep. It's just going to make that geometry look nicer. So, and again, really make it stand out against everything else, which is, you know, what we want to do. We're showing off what we made. I don't want you to be excited by the background. I want you to be excited by the stuff you made this month. Does that make sense? Hell yeah? Okay. So again, this is the skill check. So make sure that you can do this, submit that, get that easy 1% added to your grade. And again, it's just practice, because this is the exact same thing you're going to do for your week 4 assignment too. So you've got it all done already. And again, because you have to do it a little bit earlier, you can figure out what you don't understand and need help with, so we can help you with it. And that's really the goal of these skill checks. Let's figure out what you are missing information-wise. All right, any questions about the skill check? What it is we're looking for, what we need you to do? No? Okay. Any questions about your week 3 turn-in? No? Okay. Any questions about your week 4 turn-in? No. All right. Well, make sure you're, again, make sure you're finishing up those assets, get that stuff done, have instructors look at it in lab, because that's really your best opportunity to get feedback. As much as you will always get feedback, of course, when we grade your work, and we would be more than happy to go over your work with you after the fact, and hey, you know, this is what you could have done to do better, this is missing, we need to include that, this part's looking good. let's try to do some of that stuff before we turn it in, because that's just going to get you a better grade. And who doesn't want that? So again, all it takes is doing the work a little bit earlier so that you can get some feedback and earn more of those valuable points that you need to be successful. So, you know, come into the Google Hangout and see Brian or whoever else is working in there. Or again, in the lab, don't be shy, come see us. You know, I'd be more than happy to look at your model with you and tell you what you know, hey, I'm thinking of turning this in. Is there anything I've forgotten? Can you take a look at it for me? Yeah, of course. Oh, don't forget to do this. Oh, and you forgot that. And those are all points. Anything I'm pointing to and talking about, points. So it makes it easier on you if you do it that way. All righty. Well, if you don't have any more questions for me, like I said, this lecture is typically one of the shorter ones. So you're going to earn some extra time to do whatever you want, work on Maya, and get some more work done so that it's not so crazy at the end, because that's what happens. Usually every class winds down at the same time, and there's always a ton of stuff to do. So do yourself a huge favor and try to get a jump on something, because it'll help you out big time later on. All righty. Well, thank you very much, guys. You were very quiet today, but good lecture. It seems like you guys understood and had some success with this, and that's what's most important to me. So I will see you guys on Thursday. And again, we're going to be talking about composition and how we can improve the quality of the render. The idea being, how do you get somebody to look at your stuff and choose yours over someone else's? Because the reality of the situation is, you're not going to build something somebody else hasn't already built. You know, the odds are very, very rare that you're going to make something brand new. So how do I make my stuff stand out so somebody chooses me over someone else, over the millions of people who want these jobs? How do I get them to look at mine? So that's what we'll be talking about next class, and it'll be the last one. Very sad, but they all come to an end. So, but thank you very much for today, and I will see you guys on Thursday. Good luck. Yes. Good, good, good. Okay, awesome. Thank you, Brian.